So ever since we open source React, we only labeled it as a view layer. And everybody wondered, what about data fetching? What about data management? Where do you put it? How is it working? So I'm super excited about the next talk that's explaining how we do it at Facebook. And first, I'm going to come on, and Dan is coming to come on stage.
Good afternoon. Thanks for joining us today. My name's Dan Schaefer. I'm a software engineer on Facebook's product infrastructure team. And along with my colleague Jing Chen, we're going to be describing today how to solve one of the really hard problems facing developers, data fetching in increasingly complex client applications. In particular, we're going to take an early peek at how Facebook is solving these problems, and in particular, how they apply to React. So let's start by talking about client-side development today. I'm going to guess everyone in this room is at least slightly familiar with React, otherwise it's probably been a confusing morning. Most of you may have seen Flux as well. Flux is a design pattern that we've described in the past. If you've seen it, you've probably seen a diagram that looks something like this. This summarizes the general idea of Flux, which is we want to have a one-way flow of data through our system, making interactions easier to reason about. The issue is there's a missing piece here. How do we get the data from the server to the client in the first place? And especially in complex applications, once we introduce this piece, we realize that the server and the view end up being coupled together, and that makes development difficult. Let's take a pretty simple example. Let's take a list of friends that we want to render. In this case, for each friend, we're going to show a profile picture, we're going to show their name, their mutual friend count, and a button on the right that shows whether I'm friends or not. So if we were structuring this, it's actually going to be three major components, I would say. We're going to have a friend list component. The friend list component is going to contain many friend list items. And just for the sake of making our trees non-trivial, we'll add a friend info component as well that contains the name and contains the friend count. So our application looks something like this. We've got our tree of components on the client side, and we have a server-side endpoint. The server-side endpoint sends some data down to the client. Friend list receives it. Friend list passes it down to its children, and we populate the data in the tree. But of course, this is a simplification. What happens when we add some color to this? In particular, each of these three components has distinct data fetching needs. The friend list needs a count of how many friends the user has. The friend list item needs the profile picture to render on the left. The friend info needs the name and the mutual friend count. So if we look at what's actually happening on the server here, we've encoded the implementation details of all three of our components on the server side, so it knows what data to pass down. Furthermore, if we look at friend info, we've actually have the implementation details of friend info leaked to friend list item as well, because it has to know what to pass down as props. So what happens when we change friend info? Well, we're not just changing friend info, the component. We're also changing friend list item and what it passes down. We might have to change friend list depending on how we've structured things, and we certainly have to change the server side so it sends the new information. How did we get here? How did we get to a place where making a simple change to friend info required us not just to touch that component, but to touch its parents, which are potentially many in a complex application, and to touch the server-side endpoints, which again are potentially myriad in a complex application? The big problem was a lack of modularity. We wanted friend info to be a self-contained component, but it wasn't. Its implementation details were leaked to friend list item and to the server. The thing that was missing, the thing that was leaked, was a way for friend info and other components to specify what data they require. That specification didn't live in the component itself. It was spread all over the application. What we want is some way for each component to statically define its data needs in a simple way. And if it can do so in a way that each of its parents can gather up those data needs, we can gather the data specification all the way up the stack to the root. The root component can then communicate that to the server, to an endpoint. And instead of the endpoint being hard-coded to say what data is required, the endpoint can respond to this particular data specification and use that to determine what it sends to the client. From here on out, it's exactly the same diagram as before. We have an endpoint. The endpoint has the data that our application needs. It sends it to friend list. Friend list passes it down to the children. It's a subtle change, but a key one. We've taken the details about what data friend info requires and taking it out of the server where it doesn't belong and putting it into friend info where it does. Because inherently, Our rendering logic for friend info and its data specifications are tied together. We can't change one without changing the other. So having them both be in the same component makes life a lot easier. So if we want to do this, if we want to have each component be able to specify its data needs, how can we do so? We realize that our data specification has a few key properties that it needs to fulfill. First, it has to be able to describe complex data structures. If you look at the responses that we get from servers and our endpoints today, it's not rows and columns. It doesn't look like tabular data like you would get from SQL. It's complex objects. It's objects that contain arrays, that contain objects. Whatever our data specification language is, it has to be able to represent those responses. Second, it has to compose. We have to be able to take a component and take its data specification, in this case, friend info, and pass it up to its parent. Because friend list item doesn't just need to know what data it needs. It's going to be rendering a friend info. So it needs to take its specific data requirements, ask friend info for the additional data requirements, and combine it together. And that's what it passes up either to the parent or to the root, or if you are the root, then to the server. So we need a simple way of specifying our data requirements. It needs to compose, and it needs to be able to describe nested data structures. In order to figure this out, let's actually look at the response for one of these friend list items and figure out how we'd want to describe it. In this case, this is the friend list item for my co-presenter, Jing. And the response that we would get back is pretty simple. It's going to be an object that contains an ID. We can use that as a React key. It's going to have our name, so we can render it. It'll have isViewerFriend as a Boolean. That'll help us render that button on the right. It's going to have a mutual friend count. And then it's going to have a profile picture object. The profile picture object will contain a URI. It'll contain a width. It'll contain a height. So we have the response. This is our data requirements. And now we need a way of specifying that data. If we take the response and we just look at the keys and we remove the values, look at what we're left with. This describes the nested nature of our response exactly. In fact, looking at this query, you can immediately see what the response we're going to get back is. And it composes. We can take one of these data specifications and put it inside another one extremely naturally. This is GraphQL. This is the query language and API that Facebook's client applications use to describe their data requirements. Now, we're going to be talking about GraphQL in the context of React today, but it's important to note that we've been using GraphQL at Facebook for almost 2.5 years now. If you've ever used Facebook's iOS application or Android application, if on those clients you've used Newsfeed, Timeline, Groups, Events, Notifications, Bookmarks, you've had your data fetching powered by GraphQL. Facebook's client developers stopped writing dedicated endpoints almost 2 years ago because GraphQL was better for their data fetching needs. Let's talk about GraphQL in a little bit more detail. We noted if we wanted to have a response like this on the right, we would expect the query to just take the keys from the response and those become fields. But we're missing one piece here. The query here only says, for this user, I want to fetch an ID and I want to fetch a name. It doesn't say what user we're talking about. And so we're going to introduce one additional concept. We're going to introduce the idea of a call. And a call is simple as well. It has a name. In this case, it's named node. And it takes an argument. In this case, that's my user ID. And this call we're placing at the root of the tree, and we refer to it as a root call. And the root call here identifies an object in our data set. In this case, it's my user. And then the fields, ID and name, say what data we want to fetch, so we get the response on the right. Let's say our data fetching needs change. Let's say in addition to my name, we need to fetch my birthday. Well, we can update the query. We'll query for the birth date object. And then on that object, we'd like to fetch my month and my day of my birthday. And if we update the query on the left, we get the response on the right. Again, notice that the query and the response have the exact same structure. We can exactly predict what we're going to get back in the response from the query. We're missing one key piece so far, and that's the ability to traverse edges or connections, one-to-n relationships. GraphQL models this similarly, and we're going to reuse that concept we described earlier of a call. In this case, friends is a good example of a one-to-n relationship. And when we query for friends, we can use that same idea of a call, but this time put it on a field. In this case, the call's name is first, and it takes a value, and I passed 1. And so this tells the server, when I'm fetching this friends connection, only fetch the first one. Now, when we get the values here, we don't want to just get the objects. We don't want to just get users that are my friends. We want to get a cursor as well, because this is what allows us to efficiently paginate. So when I issue this query, and we get the response on the right, we're going to see we fetched one of my friends, in this case Jing, and we also got a cursor. And so now we're going to update the query on the left to ask for 2 additional friends in this list. And it's that simple. We're going to use that same concept of a call. In this case, it's a call named after. And we're going to pass the cursor in. And then we're updating the .first call to take a different argument. In this case, it takes 2. And this just tells GraphQL, in my friends connection, fetch the 2 friends that are after Jing in the list. And when we issue this query, we get exactly what we'd expect, 2 more friends. Each of the friend objects, the format of the response, is still exactly specified by the query on the left. Now that I've introduced the idea of GraphQL, I'm going to turn things over to Jing. We'll talk about using GraphQL in React.
Okay, thanks, Dan. So my name's Jing. Some of you might know me from talking about Flux in the past. But as Dan said, we don't really talk about how to solve data fetching inside of Flux. So today I'm going to talk a little bit about how you can use GraphQL queries inside your React components to specify the data that you want. Now, GraphQL allows you to specify what your response shape should look like. So we can actually use that same property for components to specify the shape of their data. So we'll use this friend list view as an example here. We'll take the friend info portion of it. And as we see, the rendering for this is pretty simple. It just expects a user object as a prop, and it takes some fields off of it. It uses name, and it uses mutualfriends.count. The problem is that your parent component here has to pass in a user object that matches this shape exactly. And the parent component for that also needs to pass in something that looks exactly the same. And so there's actually a dependency that goes up through many layers of this tree. Instead, what if we could just specify what data this component needed and have that automatically fetched for us, and have these props automatically populated? So how would we use GraphQL to specify that? Well, we want to specify the query in statics so that we can access them without instantiating the component. So here we're using ES6 template literal to get multi-line strings, but everything in between those backticks should look really familiar. That's just GraphQL. It's exactly what Dan showed you. And what we're saying here is for the query user, we expect to get a prop called user that has exactly the fields we specified in that query. So it should have a name, and it should have mutualfriends.count populated as well. What this gives us is co-location of our data queries with our rendering logic. Rather than having to have that data pass through multiple layers, we want to be able to specify it in the component itself. But this is a pretty simple component. It's only got 2 fields in it. Let's look at what it looks like once we want to nest different components. So when that happens, we really want a parent component to be able to ask its children for the data that it needs, combine that into one big query, and send that to the server in one go, rather than making multiple round trips to the server. So going back to this friend list view, we'll take a slightly bigger part of this view now. This is the friend list item component, and it just renders a profile pic and a friend info component, where friend info is the one that we just built. So what does the query for this one look like? Well, we know that friend list item doesn't require any data off of the user object. It just needs exactly the data that profile pic needs and friend info needs. So we can use that to generate our query exactly. We just fill in with the query that we get from profile pic and from friend info. Now, this means that we actually have our data right next to our render function. And here's where the modularity comes into play, right? If somebody changes friend info component to fetch a little bit more data, I don't need to update this component. And similarly, other parent components of friend info also do not need to update. All of that information is now contained inside friend info rather than leaking it into their parents. All right, so it'd be really cool to be able to do this. Let's talk a little bit about how we enable this development model at Facebook. How do we put together that query, send it to the server, and once we get the data back, how does it actually make its way down to the view? So going back to the friend list item, we'll start with the static view. Here's the query that we already wrote. And in this case, the static view is friend list item. From there, we can actually generate the query. And in this case, the query for friend list item is just made up of the queries for profile pic and for friend info. At this point, we can send the query to the server, but what we'll actually do first is flatten the query into its actual fields. And then we can dedupe any field. So if different components ask for the same field, we don't ask for it twice. The server will then respond with data that has the exact same shape as the query that we asked for. So in this case, we'll get name, mutual friends count, and a couple of fields off of profile picture. What we do at this point is we take that data that we got from the server and we put it into a general store. This is the store that is the central source of truth for all data that we've gotten from GraphQL. Now, if you're familiar with Flux, this plays a pretty similar role to the Flux store. The only difference is that this is generic. You don't have to write a user store, a profile picture store, and a friendship store. Everything is just stored in this generic store that holds all of the GraphQL data. Once we have all of the data inside of this store, we can now render our views. We can have those props populated from the store, and we can render it like a normal React component. All of that is very familiar to us. So here is the full life cycle. Oh, sorry, I'm a slide behind. All right, so here is the full life cycle of how we get that data back down to the views. We start with a static view, we generate the query from that, and once we get the data back of the same shape, we store it into a common store and use that to populate the views. Now, you might be thinking, there's a couple of extra steps in here. What is that for, right? Do we actually really need to do all of those extra steps? And the answer is that this is what it enables. It allows us to co-locate our data fetching and our rendering. But even though the query and the render are actually used in different parts of this flow, they can be in the same component. Because we specify them together, it gives you the ability to look at the two pieces and verify that they're actually in sync. It makes the components more modular, and it makes it harder to make mistakes like overfetching and underfetching. So this lifecycle is what enables that co-location, and this is what we call Relay. It's a React application framework that is the next evolution of Flux. Instead of having components, so rather than having components need to pass data to its children, we have components that can declare the data that they need and have it satisfied automatically by Relay. So let's take a look at what this means for your workflow. Let's say that we actually now need to update the query for something. Here's our original flow. As Dan said, we need to keep the server piece and the view piece in sync. So let's say that for friendless item, now I want to add the isVerified field so that I can show a little check mark next to the profile picture if the user is verified. What do I need to do to make that change? Well, here's what my text editor looks like. I have a server payload here where I need to make sure that new field is being fetched. I also have to change friendless, which is the parent for friendless item, to make sure that it's actually passing that new field down to friendless item. And I finally can change friendless item so that it's actually using that new data. So I already have 3 stores here, and I'm not even talking about any stores at all, right? In the course of normal development on a complex application, you might end up with something that looks a lot like this. So a ton of tabs, and a little bit of this is our fault because we prefix everything with FB, but this goes beyond just having a lot of tabs and needing to juggle those, right? The core of the problem here is that there's a lot of layers that need to be kept in sync in order for friendless item to actually get the correct information down at the bottom. It's a lot of juggling to keep all of that stuff in sync, and it's a pain, and it slows us down. In fact, it makes it more error-prone, too, because we end up with errors like overfetching and underfetching. With underfetching, I might end up changing this friendless item without realizing that some other component is also using friendless item. And now they're not fetching the correct data, and their app won't show the right thing. You might end up even, in cases where you're accessing fields, you might end up with a view that doesn't even render anymore. So that's underfetching. But overfetching is more insidious than that. What might happen is, a year down the road, I want to modify friendless item to no longer show as verified. So I can remove that from the render here, but how do I know for sure that I can remove it from the server data as well? It's hard, right? You have to make sure to search through all of the files and make sure that nobody else is using the same field. Instead, what I might do is I might remove it from the render and leave it in the server payload because it's safer, I know I won't break anything. But over time, this makes our applications cruftier, and it makes it less efficient. So it's overfetching a lot of data in that case. So that's overfetching. How does Relay solve both of these problems? Well, here's our workflow with Relay. We take friend list item. Now we want to do the same thing. We want to add is verified and start rendering a check mark next to the profile picture. So all we have to do is add it to the query, and then we can immediately start using it in the render function. All of the changes are in one file, and then all of the callers are automatically updated in that case. So this is what Relay does for us. It enables this kind of workflow, which makes it simple and less error-prone for a large application over time. Now, with Relay, we actually realized that because we have a central store, we can put a lot of common logic into the core. So let's look at an example of one of these. So pagination. Everyone has built pagination. Lots of views just consist of lists of things, and at the end, you want to scroll load something in or go to the next page. So let's actually build this friend list view that we've been talking about for a while. Again, the render for this is pretty simple. We take a friend list item, and we render one for every friend that we get. So we already know how to construct the query for this. We just use the query from friend list item and use that as a piece of our query. But here, we're not saying how many friends we want. So let's use the call that Dan showed us and fetch the first 10 friends. OK, so now we have 10, but how do we actually change that number when we scroll load? So what we really want is for that 10 to be a variable that we can substitute in. So let's do that instead. We'll set it to params.count, and then at the top, we'll specify that we want to use 10 for the initial load. That's our initial value. And then when we change, that query changes along with it. So in this case, what do we do now in order to scroll load? Well, it's simple. All you have to do is call this.setQueryParams with a new value for count, and you're done. Right? In this case, all I'm saying in the component is now I want 15 friends instead of 10. What Relay will do is it'll take that query param. It'll realize that we already have 10 in this list. So it'll ask the server for the next 5 after that. When the server responds with that 5, it'll come back and stitch those two pieces together to get the full 15. And when this component renders again, it'll have 15 friends instead of 10. All of that complex logic is just in one call. The stitching for lists is done behind the scenes. And you don't have to make any server changes to paginate. You don't have to deal with counts or offsets or cursors. All of that is just handled by Relay for you. All right, so there's a couple of other features in Relay that I want to go over. Go over them really quickly. All right, so query validation. GraphQL provides a schema that gives you a way to validate queries. So what Relay does is it'll consume that schema and use it in our transform pipeline to verify that all of the fields you've put into queries are actually valid queries. So if you misspell a field name, instead of having to go through and check all of your views, you find out at transform time that there's actually a problem in there. Makes it much simpler to iterate quickly. Mutations. So writes are a really big part of the application, and we can't not handle this, right? For Facebook, these might be things like adding a comment or posting a status update. In GraphQL, mutations are specified by a set of inputs, including the type of the mutation. But GraphQL mutations also allow us to query for a set of updates after the write is done that give us the updated data. And so what Relay will do is it will take that set of updated data and merge it into the central store. Now, because we have a central store that knows exactly what all of the views is asked for, it can fire subscriptions on the views whose data has updated. Now, if you've ever used Flux with React views, you've had the problem of having to hook up a store at a particular location in your React tree, right? So you end up with either re-rendering too many things and having to implement should component update, or you end up hooking up subscriptions all throughout your tree. With Relay, you don't have to deal with any of that. All of those subscriptions are done at the component level automatically, and when data changes behind the scenes, all of those views get updated automatically. It's a lot more efficient than having to wire up all of those things in Flux. So writes look kind of simple on the surface, but there's actually a lot of edge cases. We always talk about optimistic updates, error handling, and responses that come back out of order. And those are a lot of the questions that come up with Flux. So again, this is a problem that we can solve in the framework rather than having to have every product engineer solve it separately. So in Relay, what we do is we'll actually have a separate queue for all of the optimistic updates coming in. And rather than merge that into the store, we keep them in a separate queue until they've been confirmed by the server. And then when you get an error that comes back for one of those payloads, we simply pull it out of the queue and ask the views to re-render. Now what that means is that whenever you have an optimistic update, the error handler for that is built automatically. You no longer have to provide an undo payload for that optimistic update. All of that bookkeeping behind the scenes is just handled for you. All right, so we went through a bunch of stuff today. A natural question is, what is our status? So we're working on an experimental version of the mobile site that's built on top of Relay. But also the groups view that you saw in the keynote, that is built on top of Relay as well. Because Relay is built on top of React, it works great with React Native, and we've been using it internally for a little while. So we want to be able to open source both GraphQL and Relay as soon as we can. But for today's talk, we wanted to give you a glimpse into how we build applications at Facebook and how we're trying to solve problems that are common to the React applications. OK, so both Dan and I will be around for the next couple of days. So come talk to us, ask us questions. Let us know if you've run into the same problems that we have. Thanks.